Hello, in this lesson, we're going to talk about linear equations in two variables and how they help us represent relationships using straight lines. Let's get started. Let me quickly walk you through what we're going to cover in this section. By the end of this lesson, you should be able to graph linear equations, calculate slope, write equations of lines, and identify parallel and perpendicular lines. We will also connect this to real-world applications. So first, what exactly is a linear equation? A linear equation represents a straight line, and the most common way we write this is y equals mx plus b. Here, m is the slope and b is the y-intercept. Now, slope tells us how steep the line is. The larger the absolute value of the slope, the steeper the line. If the slope is positive, the line goes up, and if the slope is negative, the line goes down. Let's talk a little bit more about slope. Slope measures how much y changes relative to x. We calculate it as rise over run. So, given 2 points, the slope is m is equal to y2 minus y1 over x2 minus x1. In this example, the slope is 2, which means the line goes up 2 units for every 1 unit it moves to the right. There are two special cases you should know. A vertical line has an undefined slope, and it is written as x is equal to a. In this case, x is equal to 3. And a horizontal line has a slope 0, and it is written as y is equal to a. In this case, y is equal to 3. Now let's graph a line. We're given the equation y is equal to 2x plus 1. Since this is already in slope-intercept form, we can go straight to graphing. The y-intercept is 1, so we start at the point 0, 1. The slope is 2, so we go up 2 and write 1 to get additional points. Now let's look at a slightly different example. Here we're given x plus y is equal to 2, which is not in slope-intercept form. So the first step is to rewrite it. Y is equal to negative x plus 2. Now we can see the slope is negative 1 and the y-intercept is 2. So we start at 0, 2, then go down 1 and write 1 to graph the line. Now we're going to introduce a very important formula, the point-slope formula. This is what we use when we know the slope and 1 point on the line. The formula is y minus y1 is equal to m times x minus x1. Let's walk through an example step by step. We're given a slope of 2 and the point 2, 4. First, substitute into the formula. Y minus 4 is equal to 2 times x minus 2. Now simplify. Distribute the 2. Y minus 4 is equal to 2x minus 4. And then add 4 to both sides. That'll give us y is equal to 2x. So the equation of the line is y equals to 2x. Next, let's talk about parallel lines. Parallel lines never intersect, and they always have the same slope. So if one line has slope 2, any line parallel to it will also have slope 2. Now let's talk about perpendicular lines. Perpendicular lines intersect at a 90-degree angle. Their slopes are negative reciprocals of each other. So if one slope is 2, the perpendicular slope is negative 1/2. Let's apply what we've learned. We're given the equation 2x minus 3 is equal to 5. First, we rewrite it in slope-intercept form. That'll give us y is equal to 2/3 x minus 5/3. So the slope is 2 over 3. Since we're finding a parallel line, the slope stays the same. Now we use the point slope with the point slope form with the point 2, negative 1. That'll give us y plus 1 is equal to 2/3 times x minus 2. And this gives us the equation of the parallel line. Now let's find the perpendicular line. The original slope is 2/3, so the perpendicular slope is the negative reciprocal. That'll mean it'll be negative 3/2. Now plug it into this point slope form, and that'll give us y plus 1 is equal to negative 3/2 times x minus 2. After simplifying, we would get y is equal to negative 3/2 x plus 2. To wrap things up, linear equations always allow us to model relationships and understand how variables change together. Once you understand slope and how to write equations of lines, you have a powerful tool for solving real-world problems.